Hello everyone, welcome back. Hope you all are doing great. Guys, today I am going to discuss one very important topic of BGP protocol. This video is going to be very important, very useful for all networking professionals. So if you are a network engineer or planning to become a network engineer, then make sure you will watch this video till the end. Now without wasting our time, let's start. First of all, let's understand one issue of iBGP full mesh. Imagine a large telecom company like Airtel or AT&T having BGP routers across different regions, like one router in north region, one router in south region, some router in east region, some router in west region, like this, right? So here we have to configure full mesh iBGP session, and if this telecom provider or service provider is going to configure full mesh iBGP, then how many iBGP session will be there on each and every router. Router 1 will have one BGP session with router number 3, will have one BGP session with router number 2, will have one BGP session with router number 4, will have one BGP session with router number 5, will have one BGP session with router number 6. Similarly, router number 3 will have one BGP session with router 1, with router 2, with router number 4, with router number 5, with router number 6. Similarly, router number 2 will have one BGP session with router 1, router 2, router 4, router 1, router 3, router 4, router 6, and one with router number 5. Similarly, router number 4 will have one BGP session with router 1, router 2, router 3, one with router number 5, one with router number 6. Similarly, router number 5 will have BGP session with router number 1, router 3, router 2, router 4, and router number 6. This is my full mesh BGP session here. You can see on each and every router I have how many BGP session: 1, 2, 3, 4, 5. 5 BGP session, right? You can calculate the BGP session. There is formula, n multiply n minus 1 divided by 2, right? You will get the total number of BGP session. And here if I will talk about the scalability, this is not a scalable solution, right? And if you will not configure the full mesh iBGP session, then you know the loop avoidance mechanism. Like if you have 3 routers, R1, R2, and R3, and if R1 is advertising any prefix to R2, will R2 advertise that to R3? Answer is no. If we have iBGP session here, R1, R1, R2, and R3, right? If I am running BGP ES number 100, let's suppose on all the router, BGP ES number 100, and here is one LAN subnet, or R1 is receiving one LAN subnet 10.100.0/24, or any prefix, the public network or private network, that's not matter. What will happen here? We will have iBGP session between router 1 and router 2. We have iBGP session, and here we have one iBGP session. So R1 will advertise this 10 subnet to router number 2, but router number 2 will not advertise it to router number 3. You know this is rule, right? To avoid loop in iBGP. So if you want to advertise this 10 subnet to router number 3, you have to configure one BGP session between router 1 and router number 3 as well. This is full mesh BGP session, right? Or another way is you can configure R2 as route reflector, right? Because by default router 2 is acting as a server and their neighbors are non-client. So R2 is going to receive 10 prefix from their non-client neighbor. It will not advertise to their other non-client neighbor. I can configure this router as route reflector, RR, right? And now maybe router 1 is their client neighbor or router 3 is their client neighbor. Both will work. So now router 2 is receiving learning prefixes from their client neighbor, definitely will advertise to other client neighbor or other non-client neighbor. So this is one way, route reflector. But again, configuring so many route reflector will be difficult here. And if you don't want to configure route reflector, then you have to configure full mesh BGP session. This is the issue, right? And see, here we have issue of scalability. Like if I am going to add any new router somewhere, let's say in east region, I have added one more router number 7. Now on all the routers on all the routers BGP session will increase. Router 7, right? Router 1 will again have BGP session with router number 6. Router 3 will have BGP session with router number 6. Router 2 will have BGP session with router number 6. Router 5 will have BGP session, right? Router 6 will have BGP session with router number 6, and router 4 will also have BGP session with 6. This is going to be very complex, right? It is complex setup, right? Managing these kind of setup full mesh iBGP session is difficult. And here you can see we have only 7 routers, right? This is R7, not R6. This is R7. Imagine the big network, like as I told you, the telecom companies like your Airtel, or service provider like AT&T, Airtel, Tata. When you have hundreds of routers, thousands of routers, in that case, how you will manage the BGP? It is going to be very tough. So this is issue in iBGP. This is my issue, and hope it is clear to all of you. If it is not clear, this loop avoidance mechanism or full mesh iBGP, then you can watch my BGP playlist, which is available on my YouTube channel with name BGP, or I think CCI BGP with that name. So you can watch that, all the videos from that playlist, or you can also purchase the course from PM Networking website, pmnetworking.in. There you will find the best course for BGP, where you can master BGP from scratch to advanced with troubleshooting. Like everything is there in our BGP course. But here what we have understood now, that issue of BGP. Now Praful, what is the solution? One solution is rot reflector, but again rot reflector is not perfect solution. There is a still issue with scalability and complexity, right? So we have issue with complex iBGP full mesh session, and we need to reduce it. And here we come up with features in BGP called BGP configuration to fix it. BGP configuration, right? BGP configuration, we come up with this feature to overcome this issue. What is BGP configuration? BGP configuration is a technique used to divide large autonomous system into multiple sub autonomous systems to reduce iBGP full mesh complexity, or you can say to simplify BGP management, right? Because it's difficult to manage BGP in these kinds of scenario when you have lots of routers, right? When you have hundreds of routers, thousands of routers, and that is normal scenario in service provider, right? Having 100 routers is not like, it is common, right, in the service provider network. So at that scenario you can imagine how complex it is. So BGP configuration is going to solve this issue, right? BGP configuration is a technique to divide large autonomous into multiple sub autonomous systems to reduce iBGP full mesh complexity, to simplify the BGP management, and to improve the scalability, right? This is also not scalable, that is the issue. And again, BGP configuration, what it will do, BGP configuration is going to divide your large autonomous system into a smaller, multiple smaller autonomous system, but for outside world, for other company, it is going to behave like a single autonomous system, right? So dividing, BGP configuration is nothing but a mechanism of dividing large autonomous system into multiple smaller autonomous systems and act as a single AS to outside world, right? This is what, this is BGP configuration, right? With the help of BGP configuration you can reduce complexity, right? A company can divide large autonomous system into sub autonomous system. Now understand how it's work. Let's suppose here, what I tell you, the company has some router, one router in north region, one router in south region, one in east region, west region, like that, right? And their ES number is, let's suppose their ES number is 100, public ES number, or they can use the private ES number as well. Let's say 65,000 is the ES number. So they can divide this 65,000 ES number, which is their big autonomous system, into multiple sub autonomous system. For an example, they can divide into two sub-autonomous system like this, right? But for outside world, let's suppose this is Airtel, and here we have Tata Communication or AT&T. So if they are going to exchange some routes in between Airtel and Tata Communication, then for Tata Communication routers, this entire ES will act as a single ES, means it is only ES number 65,000. But inside the organization, this region can be, let's say, 65,001, and this region can act as a 65,002. So we have divided large autonomous system into multiple two sub-autonomous system. What is the benefit? Soon I am going to discuss. But for other side, like let's suppose we have one router here in Tata Communication. So for Tata, Airtel autonomous system is only one. It is acting as a only one ES, which is 65,000. Right. So here you will configure like neighbor, IP address, and remote ES 65,000 only. Note this sub ES number. Okay, now here to simplify this topic, I have designed this simple network. You can see this is, you can imagine like this is the service provider network where I have router 2, 3, 4, 5, right? Router 2 is the P router, provider edge router. Router 5 is also P router, provider edge router. We have two provider edge router. Router 1 is customer edge router. Router 6 is also customer edge router. Here on router number 1 I am running AS number 65,001. On router number 6 I am running AS number 65,002, and service provider is running BGP AS number 100. So for customer, service provider AS is this one, AS 100. For this customer also, service provider AS is 100. But within the service provider network, you can see I have divided my AS number into sub ES. ES number 101, ES number 102, ES number 103, ES number 104. Why? So that it can act as a eBGP. Now router 2 and router 3 will have eBGP config session, config eBGP session. So R3 is learning prefixes from R2, which is their config eBGP neighbor. It will advertise to their other eBGP neighbor, but it will not update the next hop IP address. How it is going to work, you will understand it in better way when I will configure the scenario. So see, without configuration, what will happen if I am running BGP ES number 100 only on router number 2, 3, 4, and 5. Forget about this sub ES. So what will happen? This customer R1 is going to advertise this network to R2. Here we will have eBGP session, right? And whenever router advertise prefixes to their eBGP, it will always include ES number, means ES path, right? R2 is going to advertise it to R3, but R3 will not advertise it to R4. Here you have to configure route reflector, or you have to configure neighborship between router 2 and router 4. Done. Then router 2 will advertise it to router 3 as well as to router number 4, but router 4 will not advertise it to router number 5. So now you have to configure again either route reflector or one BGP session between router 2 and router 5. So it is going to increase the complexity and it will reduce the scalability. That's why what I did, I have divided my large ES number 100 into multiple sub ES. Now you know what will happen. Router 1 is going to advertise this network to R2. R2 will advertise to their eBGP neighbor R3. R3 is acting as a eBGP neighbor. So now R3 is going to advertise it to R4. R4 is going to advertise it to R5. But when R5 will advertise to R6, it is going to remove all these sub ES from BGP path attributes. Right? When R2 will advertise to R3, it will include add this ES number 101. When R3 will advertise to R4, it will add this ES number, so ES number 101, ES number 102. And when R4 will advertise to R5, it is also going to add the ES number, so 101, 102, and 103. And customer was advertising with ES number 65,001, so 65001 will be there. Now when router 5 is going to advertise to R6, router 5 will remove these all internal sub ES. It will only advertise with this ES, and it will advertise the main ES, which is ES number 100 to their neighbor, right? So interesting and so powerful features of BGP. And in the service provider network, in the ISP network, every time you will find the configuration. Even configuration is very easy. Now let me show you the configuration. I think this topology has already configured, like IP addresses are already configured, and R2, R3, R4, R5 and R6. Let me see if I got the access to all the routers. Yeah, now router number 1, so IP interface brief exclude unassign. You can see IP address on loopback is already configured, and IP address on F0/0 is also configured. But if I will check protocol, so IP protocol, so you can see no any protocol is running, right? Protocol is not configured. On router number 2, so IP protocol, so here you can see we are running OSPF routing protocol for internal reachability, because on router number 2 I have loopback, on router number 3 also I have loopback. On all the router in service provider network has one loopback, right? And to make reachability between the loopback, we have configured IGP protocol, which is my OSPF routing protocol. So through OSPF all the loopbacks are reachable. So IP route OSPF, here you can see I have route for 3.3.3, 5.5.5, 4.4.4 done. But we are not running BGP routing protocol here. Now let's configure BGP. Okay, in the service provider network, first on R2 config T router BGP, and I am going to use here sub ES, which is 101. Router BGP sub ES, which is 101. Now I will define that this BGP ES number is a part of which main ES. This is the config ES number, right? For eBGP session, this is not my main ES. So BGP configuration identifier is 100, means this ES number 101 is the child ES of this parent ES. My parent ES is ES number 100, and inside this big ES I have created some child ES, sub ES, right? So this is the identifier 100. Now I will configure BGP and configuration peer. So peer ES number, this is now it is asking for your config ES number of peer routers. So router number 2 is going to use this config ES number 100, and in the same network we have ES number 200, 300 and sorry 102, 103 and 104. So I am going to define these all peer 102 space 103 and 104, right? And now I will configure the neighbor command, neighbor 3.3.3, and remote ES of neighbor is 102, the config ES number. The neighbor 3.3.3 update source loopback 1. Same commands now, neighbor 3.3.3 eBGP multi-hop, because for eBGP you have to configure multi-hop as well. Let me say 2. Now go to router number 3 and let me configure the BGP configuration. Router BGP ES number 102, again BGP configuration identifier is 100, and BGP peer, here BGP configuration peer is 101, 103 and 104, and after that neighbor 2.2.2.2, and remote AS of neighbor is 101, and then neighbor 2.2.2.2 update source loopback 1, and neighbor 2.2.2 eBGP multi-hop 2. Now I am expecting eBGP neighborship between router 2 and router number 3. Soon neighborship will come up if there is reachability. Do ping 2.2.2.2 and source 3.3.3.3. By the way, you can see here ping is also working, and here you can see the log message for BGP session. Now we have BGP session between router 2 and router 3. So IP BGP summary, right? You can see, and neighbor is up. If you will open the neighborship in detail here, so IP BGP, and neighbor and detail, then here you can see neighbor route is 3.3.3, remote AS is this one, and link is external link, right? Means we have eBGP neighborship, and neighbor under common administrator, right? It is under same autonomous system number, this neighbor 3.3.3 is under common administrator, means both are under ES number 100, right? But both are using config ES, eBGP config ES, different ES number, so that we can reduce the full mesh iBGP complexity, we can improve the or increase the scalability. Done. So you can check the detailed information about the neighbor also. Now I am going to configure neighborship between router 3 and router 4. Let me say neighbor 4.4.4.4, and remote AS of this neighbor is 103, and then neighbor 4.4.4.4 update source loopback 1, and neighbor 4.4.4 eBGP multi-hop 2. Go to router number 4 and let me configure the BGP router. BGP AS number 103, BGP configuration identifier is going to be 100, and BGP configuration peer is 101, 102, and 104. And after that, all neighbor command neighbor 3.3.3 or 3.3.3, and remote AS of neighbor is 102. Then neighbor 3.3.3.3 update source loopback 1, and neighbor 3.3.3 eBGP multi-hop 2. Now I am expecting BGP neighborship, eBGP neighborship between router 3 and router 4 as well, but neighbor is going to be under same administrator. You can see here the log message. Now let me configure another neighbor here, neighbor 5.5.5.5, and remote AS is 104, neighbor 5.5.5.5, and update source loopback 1, and neighbor 5.5.5 eBGP multi-hop 2. Go to router number 5 finally, and let me configure BGP here. Router BGP S number 104, BGP configuration identifier is 100, and BGP peer, BGP configuration peer 101, 102, and 100. Sorry, let me say no to this command, and let me add properly 103. And now neighbor 4.4.4.4 update source loopback 1. First of all, remote ES is going to be 103, and then neighbor 4.4.4.4, and update source loopback 1, and neighbor 4.4.4 eBGP multi-hop 2. Now I am expecting eBGP neighborship between router 4 and router 5 also, you can see here, right? But right now we have not advertised any prefix in BGP, but you can verify the neighborship. Now we have neighborship. Before configuring BGP between router 1 2, means between customer edge and provider edge, let me create one loopback on router number 2, and let me advertise that into BGP. Right here I am assuming you are familiar with service provider network, right? Router 2 is the P router, router 5 is also P router, provider edge. Router 1 and router 6 are customer edge, and router 3 and router 4 are core routers, right? These are core provider routers. Done. Now on provider edge router, means on router number 2, if I am going to create any loopback, let's say interface loopback 10, and IP address 10.1.1.1.255.255.255.0, exit router BGP AS number 101, and network 10.1.1.0 mask 255.255.255.0, and check the BGP table. So IP BGP. Now you can see this prefix is installed in BGP table 10.1.0. This is self-advertised prefix, that's why next hop is 0.0.0. For self-advertised prefix, you can see the weight attribute, rest all the attributes you can see, right? Now router 2 is going to advertise it to R3, to their neighbor. Let me take you to R2. So IP BGP. Now you can see 10.1.1.0/24 prefix is coming. This prefix is valid as well as best. Next hop IP address is the 2.2.2, right? R2 loopback interface IP address, and here you can see the local preference value, weight, and ES path, right? So router number 2 is advertising ES path as well, the ES number. Now when R3 will advertise it to R4, it will not change the next hop. You know, whenever BGP router advertise prefixes to their eBGP, it always modify the next hop IP address. And for iBGP, router does not advertise the prefix learned through iBGP neighbor to other iBGP neighbor. Here we have eBGP, but this is not real iBGP. This is config iBGP session. Because of that, router 3 is not going to update next hop IP address. So go to router number 4 and check BGP table. So IP BGP. Here you can see next hop is still 2.2.2. Router 3 has not changed the next hop for this network. And router 2 has added their ES number. Now two ES paths are there, 101 and 102. Router 4 is going to also advertise it to router number 5. So IP BGP next hop is same, not updated by eBGP neighbor, because this is config eBGP neighbor. This is rule you have to remember, and all the routers are including their ES path. Great. Now from router number 2 I am going to remove this loopback. Router BGP ES number 101 and no to this network command. Right now let me configure BGP between customer edge and provider edge. 12.1.1.1 and remote AS is 65,001 and go to router number 1 and configure here BGP neighborship router BGP 65,001 and neighbor 12.1.1.2 and remote AS is 100. Right here I am not going to say remote AS 101, right, because customer will no service provider routers with main AS, right? What I told you, for outside world this service provider is running single AS, right? So it will act as a single AS. So on customer is AS number 100. And now I am expecting BGP session. Till then let me advertise the LAN prefix in BGP 192.168.1.0 and you can see the log message 255.255.255.0. Here you can see log message neighborship is up. Let me hit enter. Now router 1 is going to advertise it in BGP, so IP BGP. Great. Self advertise prefix. Now R1 will advertise it to R2. Let me take you to show you the BGP table of R2. So IP BGP, you can see R2 is learning this LAN prefix 192.160.1.0. This prefix is valid as well as best. Next hop IP address is 12.1. Metric attribute is 0, local preference null, weight 0 and ES path is 65,001. Great. Now router 2 is going to advertise it to router number 3. Yes, it will advertise. So IP BGP, you can see this prefix is advertised to by router number 2 to router number 3, but this is not valid, only not best, only valid. Why? Because of next hop is 12.1.1.1. what I told you, routers config router BGP router does not modify the next hop address while advertising prefixes to their config eBGP neighbor, right? So same thing is happening. Router 2 is not advertising the updating the next hop IP address, and R3 has learned the customer prefix with customer next hop IP address, customer IP address, but this is not reachable, right? Like this interface IP address is unknown for provider routers, so it will not install in the routing table. So IP route, so IP route and BGP, you can see it is not learning any prefix through BGP, and router 3 will not advertise it to router number 4 as well, right? Not because of iBGP loop, it will not advertise because this prefix is not valid and best. So on router number 2 I am going to update the next hop router BGP AS number 101, and I am saying neighbor 3.3.3.3 next hop self. Here you can use next hop self command because this is border router. And now on router number 3, so I clear IP BGP star soft in and then so IP BGP. Now you can see this prefix is valid as well as best, and router 2 has updated the next hop IP address, right? And here you can see the ES path route. Now two ES paths are there. This ES path is the main ES number which customer is advertising, and in the bracket it has added the config ES, configuration ES is it in bracket, you can see. Now router 3 will install this in routing table, so IP route BGP yes has installed. Router 3 will also advertise to other config eBGP neighbor. Go to R4 and check BGP table. Here you can see, and next hop is 2.2.2. R3 has not updated the next hop IP address, but no problem. This is the IP address of service provider router loopback, so it is reachable. And here you can see in the bracket, router 3 has also added their config ES number, means sub ES. Correct? 1 minute, guys. Okay, config ES number. And now router 4 is going to advertise it to router number 5. So IP BGP, here you can see 192.168.1.0, next hop is 2.2.2, and router 4 has also added their ES number, sub ES number. But when router 5 will advertise to R6, router 5 is going to remove these all sub ES, because customer will never know about this config ES number, right? The sub ES. Customer is knowing only ES number 100, the main ES. Okay, so now go to R6 and check BGP table, but here we have not configured the BGP till now. Let me configure it. Router BGP ES number is going to be 100, sorry, I am saying 100, 104, and neighbor 56.1.1.6, and remote ES is 65,002, 65,002. And go to router number 6, config T, router BGP 65,002, and neighbor 56.1.1.5, and remote ES 100, 100, not 104. Now here I am expecting BGP session. So IP BGP, here you can see the log message, and now let me show you the BGP table. So IP BGP, here you can see customer is receiving this prefix with only two ES path, 100, which is the service provider ES number, and 65,001, R1 is advertising that. Getting my point? So customers will only know about the main ES of provider, right? My miss, for outside world, service provider is running only one ES number, which is ES number 100, but inside their ES they have configured many eBGP session. Now they don't need to create full mesh iBGP session, they don't need to configure route reflector, right? Similarly here, either you can divide this big ES number into two sub ES, or you can divide it like this. This can be in ES number 65,001, this can be in 65,002, this can be in 65,003, this can be in 65,004, like that, right? Sub ES. But for outside, this service provider is using only one ES, which is ES 65,000. Hope it is clear to you guys. This is very important topic of BGP, and we are using this feature in the service provider network, in large network. Okay, now if you have any doubt, anything is not clear to you, please let me know in the comment section. Definitely I will make one more video on it. And if this video was helpful for you, if you have learned something from this video, then please hit on like button and share your feedback in the comment section. Even if you don't want to type long sentence, just type helpful in the comment section. If you will type helpful in the comment section, it will motivate me to make more videos like this. Any doubt, let me know in the comment section. Thank you so much for watching. We'll meet soon in next video. Till then, stay safe. Bye bye. That's all for today.